this video, we'll cover what an Algebra 1 class does with graphing lines. It'll start off with plotting points and how to do that, talking about whether or not something is a solution, and then how to graph a line, and finally, what is a function, or how do we know if something is or is not a function. So to start off here on number 1, we're just plotting and labeling each point that they gave us. So the label part of that, since they're labeled A, B, C, and D on the instructions, just means to put that letter next to the appropriate point. And so for plotting points, we want to use X, comma, Y, which is in alphabetical order. So we always go left or right first and then up and down. So 3, comma, -3, we'd go to the right 3 and then down 3. And that is A. B, we'd go right 1 and up 6. C is left 2 and not up or down at all. D is not left or right, just up 1. The common mistakes that happen with plotting points are either just for like randomly getting it backwards and going up and down, then left and right, or C and D if you're not paying attention to where the 0 is. I guess that's the same thing, that it's easier to mix up C and D, I feel like, than just if it's like A and B. So watch out, just be careful. Left and right first, up and down second. On number 2, it asks us to decide algebraically whether each ordered pair is a solution to the given equation. So in order for us to decide algebraically, we better do some algebra. We are going to plug in, starting with A, the 0 and the -4, where X and Y are. We're going to see if this ends up being true. Does the left side really equal the right side? Well, 3 times 0 is 0. -4 times -4 is +16. And it is true that 0 plus 16 equals 16. So we would say that this is a solution. Now, one of the things with that is it asks us to do this algebraically, so if we don't show our work and just say solution or not a solution, then we won't get all of the credit for that because we didn't do what we were asked to do. And then there's also that whole like showing your work thing that math teachers are pretty gung-ho about. On B, let's plug in 4 for X and -1 for Y. And that gives us 12 plus 4 equals 16. 16 equals 16. So this is also a solution. And I made these both solutions to show that, there's no guarantee that one will be and one won't be. They could both be, neither of them could be, but it's important that we show our work for how we come to that conclusion. And then it's important for us to be careful with our calculations. If we miss a negative somewhere, then we'll likely think it's not a solution or is a solution whenever it should be the opposite. 3 and 4, we want to sketch the graph of each line, and both of these have to do with X and Y-intercepts. On 3, they just give us the X-intercept and say that's 2. So we go on the X-axis and mark 2. On the Y-axis, our Y-intercept is 5. If those are our intercepts, now we know 2 points, and we just need to connect the line that goes between them and past them. On 4, it says find the X and Y-intercepts, then sketch the graph of each line. So in order to find the X and Y-intercepts, that's where we put a 0 in for X and solve, and then we put a 0 in for Y and solve. So if I have 0 minus y equals 4, well, the 0 is basically just going to go away in both of these cases. -y equals 4, we'd multiply or divide by a -1 to move that negative over to the other side. and then this is just x equals 4, since it was a positive x. So we mark those on our graph. The x-intercept is 4, the y-intercept is -1, and we draw the line between them and past them. And that's how we use intercepts. The slope of a line that passes through a pair of points, there's a formula that we use, and it basically amounts to subtracting our y's over subtracting our x's. We do have to subtract them in a certain order. So we use this formula, y2 minus y1 over x2 minus x1. The way we know what those things are is we label our first point x1 and y1. That's what the ones are there for, to say, hey, this is my first point. And then we label the second one x2 and y2. Then to our formula, m equals -19. Minus is in our formula, and then we also have a negative from the number y1. So that will switch to a positive here in a sec when we work this out. And we have x2, which is -6, minus a -6 from x1. So on both of these, on top and bottom, a negative or minusing a negative changes to plus. They cancel each other out and make those positive. So on top, we get -1, and on bottom, we get 0. Now, this is something that has a better answer, a correct answer. -1 divided by 0, we're not allowed to divide by 0. That's not something that makes any sense. If you have something and want to divide it into 0 groups, and you try to think of each group, like that doesn't make any sense. So we call this undefined. And it's important that we understand that 0 on bottom is undefined, and don't get it confused with the 0 on top, which 0 on top is actually 0. These next two problems should be pretty similar. We just work through, we can label them x1, y1, or you may not need to label them if you can keep track in your head of which one is which. We'll do -10 minus a -17. And then -19 minus 9. So this is going to change to pluses, and we get 7 over -19 minus 9 is -28. Anytime we have a fraction, we want to simplify. You may not want to, but your teacher wants you to. A negative on bottom is going to make this negative overall, and 7 over 28 changes to 1/4. So -1/4 is our answer. Finally, label x1, y1, x2, y2, fill in our formula, 20 minus 20 over -2 minus -9, so plus plus. This is 0 over 7. 0 on top is 0, which when you circle makes it look like a donut. Our slope on that one is 0. All right. This says sketch the graph of each line, and it doesn't specify a way that we need to do that. So the easiest way, once we look at these problems, will be to use slope-intercept form, if possible. 8 is a special case that we just really have to kind of remember. When there's not a y, that means our slope is undefined, and that our line is a vertical line that goes through whatever number. Basically what's happening is if x is 2, then x is 2 all the time, which makes it this line. Because on this line, you have points like 2, 0, 2, 1, 2, 2, 2, 3. All of how we get that line. On number 9, this is in slope-intercept form. Our slope is 4. our y-intercept is also 4. And so we're going to start on the y-axis at 4 and then rise and run based on our slope. Now, we don't have room to go up 4 and right 1, so we have to go the other direction. We're going to go down 4 and left 1. We do the exact opposite when we don't have room on a graph, because it's like saying -4 over -1. Those negatives would cancel and still give us a positive slope like what we want. And so that's why we're allowed to do that, to just go the opposite way. Ten is in slope-intercept form, even though it doesn't have an x. What is happening is this is like there is a 0x. So this is a line that has no slope, which means it's a horizontal line. So it goes through -5 on the y-axis, because that's its y-intercept, and then we just go left and right. We run left and right. That's a really terrible line, but I'm drawing on a computer, and that's hard. 11, our slope and our y-intercept are both 1. So we start at 1 on the y-axis, and then we can go up 1 and right 1. We go down 1 and left 1. There's our answer. And then 12, these do not have the same number, which might be helpful. This is our y-intercept, so we start at -3. This is our slope, so we're going to go up 4 and right 5. My lines are on point. On 13 and 14, we're going to write each equation in slope-intercept form and then sketch the graph of the line. So if slope-intercept form is y equals mx plus b, then what that means is that we want to solve for y. So when we solve for y, we always start by moving x, either by adding it over to the other side or subtracting it. And that's based on whether it's positive or negative. A positive 5x means we're going to subtract 5x from both sides. And we get 3y equals -5x plus 12. Then we take whatever's in front of y and we divide it by 3. When we do that, it divides everything by 3. So y equals -5/3 x plus 4. So our y-intercept is 4. Our slope is -5/3. So we can either think of that as going down and to the right, down 5, right 3, or up and to the left. We don't have room to go up and to the left, so I'd rather go down and to the right. So down 5, right 4. And then 14 is really easy to solve for y because all we have to do is subtract that x over. And we get y equals -x minus 3. So we're going to start down here at -3 for the y-intercept. And then our slope is -1. So we're going to make it a fraction, down 1, right 1. The deal with negative slopes is that you only go negative for either the rise or the run. The negative doesn't make both of them negative. So we either think of it as though it's on the top, so we can go down 1 and right 1, or like it's on bottom, so up 1 and left 1. On 15, we want to write the equation in the form ax plus function y equals ax plus b. So it's kind of like we're trying to write this in slope-intercept form in a way. There's just no y for us to solve for. Right now, we want to get everything on one side so that the right side in this case is 0. So I'm going to add 20 to both sides. And that gives me, I'll rearrange this, I'll put 4x first. And then -10 plus 20 is 10. and that equals 0 because I got rid of everything that was on the right side, so there's nothing left to go over there. This is ax plus b equals 0 form because we have a number x plus a number equals 0. We're going to change this now to the related function y equals ax plus b. What's happening is instead of having 0, we're changing it to y. And the reason we can do that is that makes us look at where y would be 0 when we graph it, which is what we'll do in the next couple of problems. But make sure that you have both of those, as your answer, in your answer. And that has to do with problems like these, that we want to solve the equation algebraically, and then we're going to check our solution graphically. We're basically doing the same problem twice, 2 different ways. So I'm going to rewrite the problem to help me do that. I want to start off by solving this the good old-fashioned way, where I do things like subtract 5 and get negative 4x equals 8. And then I want to divide by negative 4 and get x equals negative 2. So that is the answer to this equation. We're going to do it again. We're going to check that we got it right by graphing. And to do that, we do what we did on 15, where we get everything on one side. So that's negative 4x minus 8 equals 0. So we're going to graph y equals negative 4x minus 8. So that starts down here at negative 8, goes down 4 and right 1, but that doesn't help me get closer to the x-axis. I want to see where this line goes through the x-axis. So I'm going to go up 4 and left 1, because my slope is negative. I want to go all the way through the x-axis. If I don't make it to the x-axis, then there wasn't really much point in me even doing this, because what I want to see is where it goes through, which is at negative 2, which means that we got our answer right. If we do it 2 different ways and get the same answer, then it's a pretty strong likelihood that we got it right. So on 17, we've got a fraction that might make us a little wary, but I think it'll be okay. We're going to subtract 4 from both sides. Get 1/3 x equals 1. To finish solving this, the easiest thing to do is to times by 3 on both sides. You also could think 1/3 of what gives me 1. And that might. The reason we multiply by 3 is to cancel the 3's out, and we get 3. So now I'm going to do it again, where I just get everything on the same side. Subtract 5 and get 1/3 x minus 1 equals 0. That's y equals 1/3 x minus 1. Even though I know that it should go through 3, I still want to graph this line just by looking at the equation, because I don't want to let the fact that I think I know the answer cause me to maybe graph this wrong, because if I got the wrong answer, if I know what it's supposed to go through, let me, put that on the graph, well, we won't be able to figure out that we got it wrong, which is the whole point. So make sure that you actually are graphing this equation so that you can actually check. This really does go through x equals 3, so we did a good job. The rest of this has to do with functions. The vertical line test is where if you draw a vertical line and it only goes through the graph once, no matter where you draw the vertical line on the graph, then it passes the vertical line test and it is a function. If it goes through more than once, and it's anywhere on the graph, so it doesn't matter that over here it only goes through once. It just matters that somewhere on the graph it goes through multiple times. That's not a function. So on 18, I would say that it is a function. And on 19, I would say that it is not a function. That is if we're given graphs. Really, the only time we use a vertical line test is when we have a graph. Technically, we could take other information and graph it and then use that to do the vertical line test. Sometimes that's more work than we need to do. Like graphing 20 through 23 here is more work than we really need to do when we can just look at this and figure out if they're functions or not. On 20, it is not a function, and it asks us to explain why. So we would say not a function because the reason it's not a function is that the 0 is going to two different things, and that is not okay. So not a function because 0 has two outputs. To be a function, each input can only have one output because 0 has two outputs. On 21, it is a function because each thing is going to one output. 1's going to -8, 2's going to -9, 3's going to -7. So there's not any repeated inputs. They're all different. So our domain is a list of the inputs we have, and our range is the lists of the outputs that we have. On 22, when we have it in table form, it really works out to just look for whether or not there are repeated values in the input column. Because if there's not, then 0 has an output, 1 has an output, 2 has an output, so that's a function. None of them had multiple outputs. So our domain is the inputs, our range is our outputs. On 23, we have 5 listed more than once, so that's saying that 5 is going to 0 and 5 is also going to 9. That is not okay if we're talking about functions. So not a function because 5 has two outputs. The last thing here is dealing with function notation. And so function notation is where we have f of x instead of y. And it's not that we're saying f times x, we're saying to take these things and put them where x is. We're saying I have a function f and it has a variable x. And then we go through and we replace that variable with other things like the number 1. So I do 2 times 1 plus 3 and get 2 plus 3, which is 5. So f of 1 equals 5. Then I'm going to do the same thing with 0. And get 3. And then I do the same thing with -2. And get -4 plus 3, which is -1. So it's asking me basically to do 3 different things. So it's like I have 3 different answers. And on G, I plug in 1. The word evaluate, by the way, is a word that means come to an answer if possible. So because I have -1 plus 5, then I can figure out what -1 plus 5 is. And I would go all the way until I have just a number, -0 plus 5. Well, it's still 5. And -2. What that will do is a -2 is really a +2 plus 5, so that's 7. And that's what we have for Chapter 4 in Algebra 1.